Lambda functions in Python are anonymous functions defined with the lambda keyword. They can take any number of arguments but have a single expression. Ideal for short, throwaway functions, they are often used in higher-order functions like map, filter, and reduce, enabling concise and efficient code in functional programming. Lambda functions in Python are anonymous, inline functions defined using the lambda keyword. They are compact single-expression functions ideal for simple, one-time operations. This chapter will explore their syntax, characteristics, and practical applications in functional programming. Lambda functions are anonymous, inline functions created with the lambda keyword. They are compact, single-expression functions that automatically return values. Key features include no explicit return statement, single expression limitation, and the ability to accept multiple arguments. Ideal for simple, one-time operations, they follow the syntax. Lambda arguments, expression. Lambda functions offer concise syntax, ideal for quick operations without full function definitions, reducing code clutter. They excel as functional arguments, seamlessly integrating with higher-order functions like map, filter, and sorted. For simple transformations, lambdas maintain code clarity by keeping logic inline, avoiding scattered helper functions. Explore 3 fundamental lambda patterns: squaring a number with lambda x, x cow 2, checking even or odd using lambda x, even if x% 2, 0 else odd, and finding the maximum of 2 values with lambda a, b, a if a, b else b, b, a if a greater than b else b. These examples illustrate concise, inline logic for common tasks. Observe how lambda functions operate in real time within an interactive Python environment. The square lambda computes the square of a number, even or odd, determines if a number is even or odd, and max value identifies the larger of 2 numbers. These examples illustrate the concise and powerful nature of lambda expressions. Lambda functions can be seamlessly integrated with built-in functions to enhance code efficiency. They allow for concise, inline function definitions, perfect for operations like filtering, mapping, and reducing data. This approach minimizes boilerplate code, making scripts more readable and maintainable, especially when combined with functions like map, filter, and reduce. The map function applies a specified function to each element in an iterable, returning a map object. For instance, doubling numbers in a list can be achieved with map lambda x, x, 2 numbers. This approach enhances code readability and efficiency by eliminating explicit loops. Remember, map is lazy in Python 3, requiring list to materialize results. The filter function creates an iterator by selecting elements from an iterable that satisfy a given condition. Define a lambda function that returns true or false, apply it to your data using filter, and convert the result to a list. For example, filtering even numbers from a list yields 2, 4, 6, 8, 10. The reduce function, imported from functools, performs a rolling computation on sequential pairs in an iterable, reducing it to a single value. For example, multiplying numbers 1, 2, 3, 4 with reduce lambda x, y numbers results in 24. This process involves multiplying 1 by 2, then 2 by 3, and finally 6 by 4. The sorted function's key parameter allows custom sorting using lambda expressions. For example, sorting words by length, date, apple, cherry, banana. Sorting tuples by grades, Bob, 75, Alice, 85, Carol, 90. Reverse sorting numbers, 9, 8, 5, 2, 1. This flexibility enhances data organization in Python. Lambda functions are frequently used with built-in functions like map and filter in Python. These functions are popular for their intuitive application in data transformation workflows, allowing concise and efficient data manipulation. Understanding their usage can significantly enhance your ability to write clean and effective Python code. Lambda functions can be enhanced with Python's ternary operator, allowing for concise conditional logic. For instance, a lambda can determine the maximum of two numbers or classify grades based on scores. Nested conditions further extend this capability, enabling complex decision-making within a single expression, such as classifying numbers as positive, 0, or negative. Lambda functions can utilize Python's ternary operator for concise conditional logic. For instance, a lambda can determine the maximum of two numbers. Max func equals lambda x, y, x, if x greater than y else y. Similarly, a grade classifier can be implemented. Grade r lambda score, pass, if score, 60, else fail. These examples illustrate compact decision-making. Lambda functions can capture variables from their enclosing scope, creating closures that maintain state across invocations. For example, a multiplier function returns a lambda that remembers the multiplier value. Closures enable patterns like function factories and decorators, maintaining private state and enhancing lambda functions' versatility beyond simple expressions.